A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
I was looking at a pull request yesterday that had about 4 lines of actual application logic and 300 lines of auto-generated database migration code, and it hit me just how much of a tax we pay to the relational gods. Every time we want to add a simple feature, we have to navigate this massive friction between our ideas and the underlying storage. Today's prompt from Daniel is about that exact friction, specifically the shift from manual, rigid SQL schema migrations to this new world of AI-driven database evolution. He's asking if we are finally moving past the era where the schema acts as a straitjacket for our ideas, moving from designing for eternity to iterating for today.
It is the ultimate bottleneck, corn. I am Herman Pobbleberry, and I have spent more hours than I care to admit debugging why a migration that worked perfectly in a staging environment decided to lock a production table for 20 minutes. The fundamental issue is that code is relatively easy to iterate on because it is often stateless, but a database is the ultimate stateful beast. You cannot just swap it out. You have to transform it bit by bit while it is still running, and that is where the grind happens. We have spent decades treating the schema like a sacred, immutable contract, but that contract is starting to feel more like a prison cell.
Daniel mentioned this idea of the schema being a straitjacket, and I think that is a perfect way to put it. When you are in the early stages of building a feature, you want to move fast. You want to experiment with how data relates to other data. But the moment you commit to a SQL schema, you have essentially locked yourself into a specific way of thinking. If you want to change your mind, you have to write a migration, test it, ensure it is reversible, and make sure it does not break the object relational mapping layer. It feels like we are trying to do high-speed maneuvers in a container ship. Why has this remained the most manual, painful part of the stack? We have automated deployment, we have automated testing, we have serverless scaling, yet we are still manually managing these migration files in our Git repositories like they are ancient scrolls.
It is because the stakes are so high. If you mess up a deployment of a web server, you just roll back the container. If you mess up a database migration that deletes a column or corrupts data, you are looking at a multi-hour restore from backups. That fear has kept the process very conservative and very manual, but we are seeing that change now because of the quality of the reasoning we can get from large language models. As of March 2026, we are seeing tools like Claude Code achieving over an 85% success rate on standard CRUD schema migrations without any human intervention. That is a staggering number when you consider how complex these transformations can be.
This is where Daniel's point about Claude Code and other agents comes in. He is suggesting that these agents are becoming a powerful weapon to overcome this hurdle. Instead of me sitting there trying to figure out the specific syntax for a many-to-many relationship in a migration file, I can just tell an agent what I want the feature to do. But I want to dig into the mechanics of this. How does an agent actually parse a natural language requirement into valid data definition language, or DDL?
The shift here is moving from imperative instructions to declarative intent. In the old way, you had to tell the computer exactly how to change the database. Step 1, create this table. Step 2, add this foreign key. Step 3, create this index. With an agent like Claude Code, you are describing the desired end state. You say, I need users to be able to join multiple organizations, and each organization should have a tiered subscription level. The agent then looks at your current schema, understands the relational integrity requirements, and generates the necessary SQL to get you there. It is looking at the entire context of your application, not just the database.
I have been playing around with this, and what is impressive is not just that it writes the code, but that it understands the nuances of the specific database engine. If I'm using Postgres, It knows about specific column types or how to handle JSON-B fields. But I wonder, is a generalist model like Claude 3.5 or 4.0 really the best tool for this? Or are we going to see specialized SQL native fine-tunes that just live and breathe relational theory?
This is the big debate right now. The generalist models are surprisingly good because SQL is one of the most well-documented languages in existence. There are millions of examples of good and bad migrations in their training data. However, there is a limit to generalist reasoning when you get into very complex, high-performance scenarios. For example, if you have a table with 10 million rows and you want to add a column with a default value, a generalist agent might just write a simple alter table command. A specialist tool or a fine-tuned model, something trained specifically on the deep internals of Postgres or MySQL, would know that in older versions or specific configurations, that command would lock the entire table for the duration of the update. It would instead suggest a multi-step migration to avoid downtime.
That is a crucial distinction. It is the difference between valid SQL and production-ready SQL. I think about what we discussed in episode 1209 regarding the agent-first shift and the dual-track API tags. If we are building systems where agents are the primary developers, they cannot be slowed down by the manual migration grind. The dual-track API tax is directly exacerbated by manual migration management because the database schema often lags behind the agent-facing API. If the agent is trying to build a new endpoint but has to wait for a human to approve a schema change, the whole promise of agentic speed falls apart.
And that brings up the question of relational integrity. Can an LLM actually understand the deep implications of foreign key constraints? When you add a foreign key, you are not just linking two tables. You are defining how data can be deleted, how it can be updated, and how the database engine should optimize queries. I have seen agents handle this surprisingly well by looking at the entire codebase. They do not just look at the database schema, they look at the application logic to see how the data is actually being used. They can infer that a certain field should be a foreign key even if it was not explicitly defined as one in the prompt, simply because they see it being used in join queries elsewhere in the code.
It is almost like the agent is acting as a temporary database administrator. It is holding the entire graph of the application in its context window. But even if it is 85% successful, that remaining 15% is where the nightmares live. How do we trust an agent to handle the index optimization? If it suggests a GIN index for a search feature, is it doing that because it is the right technical choice or because it saw it in a tutorial once?
This is where the human in the loop becomes essential, but the role of the human changes. Instead of being the one who grinds out the code, the human becomes the reviewer who validates the architectural decisions. You are looking at the migration the agent generated and checking if the indexing strategy makes sense for your expected load. The agent does the heavy lifting of the boilerplate, which, let's be honest, is 90% of the work. But we also have to talk about the risk of hallucination. An agent might generate SQL that looks perfect, but uses a function that does not exist in your specific version of the database. That is why we need specialized validation layers that sit between the agent and the database.
I want to push on this idea of the migration lifecycle. Daniel asked a really provocative question. Should migrations always be run one by one and kept in a permanent history, or can we live on the edge and discard them once the database has been validated? This goes against everything I was taught about database management. The migration history is supposed to be the source of truth. It is the record of how we got from point A to point B.
It is a radical idea known as the ephemeral migration hypothesis. It makes more sense when you think about the database as a state rather than a sequence of events. In the traditional world, your migration folder is a historical record of every change since day one. But as that folder grows to hundreds of files, it becomes a liability. It is hard to manage, it slows down test suites, and it often contains old logic that is no longer relevant. If you have 500 migrations, and migration number 10 adds a column that migration number 50 deletes, why are you still carrying that baggage?
So, instead of saying, run migration 001 through 500, you just say, here is the target schema, make the database look like this. It is like how Terraform or other infrastructure as code tools work. You define the state, and the provider figures out how to get there.
Precisely. You use a tool to compare the current state of the database with the desired state defined in your code. The tool then generates a temporary ephemeral migration to bridge that gap. Once the migration is successful and the database matches the code, you do not need that migration file anymore. You just keep the updated schema definition. This eliminates the migration conflict in Git, where two developers both create a migration with the same sequence number. In an ephemeral world, there are no sequence numbers, only the final state.
But the difference between a server and a database is that if you delete a server and recreate it, no one cares. If you delete a table and recreate it, you just lost your business. How do you handle the data transformation in an ephemeral world? If I am moving data from one table to another, that is not just a structural change. It is a data movement change.
That is the hardest part. Simple structural changes like adding a column are easy to automate. Data transformations, like splitting a full name column into first and last name, are much harder. In those cases, you still need a script that tells the database how to move the data. But even there, an AI agent can generate that transformation script, you run it, you verify the data is correct, and then you move on. You do not necessarily need to keep that script in your main repository for the next 5 years. You treat the transformation as a one-time event, not a permanent piece of your infrastructure.
Let's look at a hypothetical case study. Imagine a startup using AI to iterate on their schema daily. They do not have a migrations folder. They have a single schema file that represents the truth. When they want to add a feature, the agent updates that schema file, generates the diff, applies it to a shadow database with production-like data, runs the tests, and if everything passes, it applies it to production. No human ever writes a line of SQL. Is that a dream or a nightmare?
For most people today, it sounds like a nightmare. But for a team moving at the speed of AI, it is the only way to survive. The risk of schema drift, where the production database ends up in a state that does not match the code, is real. But you solve that with constant automated auditing. Instead of a migration script, you have a migration auditor. This auditor is an agentic process that validates the schema state at every step. It ensures that foreign keys are still valid, that indexes are actually being used, and that performance has not regressed.
This connects back to episode 1212 in the Postgres Vector Revolution. We talked about how adding vector capabilities to a relational database reduces the need for a sprawling infrastructure. If the database itself is becoming more capable, the need for rigid, manual migrations becomes even more of a bottleneck. We want to be able to add a vector column or a new index as easily as we add a new function to our code. If I can add a vector search feature by just describing it to an agent, and that agent handles the Postgres extension, the new column, and the HNSW index, I have saved days of work.
And that is the key. The database is no longer this scary static thing in the basement. It becomes a fluid part of the application logic. But we have to address the misconception that AI agents are only good at writing code and not at understanding relational theory. People think agents just guess what comes next, but when you give them the full context of a schema and the documentation for the database engine, they are actually very good at applying relational principles. They can normalize a messy table structure better than many junior developers because they have seen every possible way to do it wrong.
I love that term you used earlier, a migration auditor. Imagine a system where the agent proposes a change, and another specialized model runs a series of simulations. It clones a subset of the production data, applies the change, runs a battery of common queries, and reports back on the performance impact. If the latency on a critical join goes up by 20%, the auditor flags it and says, "You need an index here before this can go to production." That would take so much of the anxiety out of the process. Right now, most developers are just crossing their fingers when they run a migration on production.
It also changes the way we think about the database administrator role. In an AI-first world, the DBA becomes more of an architect who defines the high-level constraints and policies that the agents have to follow. They are not writing the SQL, they are writing the rules that govern how the SQL is generated. It is a shift from micromanagement to policy management. You tell the agent all tables must have an updated at timestamp, all foreign keys must have an index, and no table can exceed 50 columns. The agent then operates within those guardrails.
It is much more scalable. You are effectively building a self-healing, self-evolving data layer. But let's get practical for the listeners. If someone is currently stuck in migration hell, how do they start moving toward this agentic model without blowing up their production database?
The first actionable insight is to use AI for schema refactoring rather than schema creation. Do not start by letting an agent build your whole database. Instead, point an agent at your existing schema and ask it to find missing indexes, redundant columns, or normalization opportunities. This builds trust in the agent's understanding of your specific domain. You will be surprised at how many small optimizations it can find that a human would overlook.
Another practical step is the automatic generation of rollback scripts. One of the most tedious parts of writing a migration is writing the down migration, the part that undoes the change if something goes wrong. Agents are incredibly good at this because it is a deterministic transformation. If you tell an agent how to add a column, it knows exactly how to remove it. You should make it a policy that every agent-generated migration must come with a verified, tested rollback script.
And you can use AI to generate synthetic data that mirrors your production distribution. Before you run a migration, have an agent generate 1,000,000 rows of fake data that follows the same patterns as your real data. Run the migration against that. It is a much better test than just running it against a 5-row development database. This is how you mitigate the risk of those 20-minute table locks we talked about earlier.
I am curious about your thoughts on the long-term future of SQL itself. If we have these layers of abstraction and these powerful agents doing the heavy lifting, do we eventually stop writing SQL entirely? Does it become like assembly language, something that is still there under the hood but that only a tiny fraction of developers ever touch?
I think we are already seeing that trend. SQL is remarkably resilient because the relational model is fundamentally sound, but the way we interact with it is changing. We are moving from talking to a database to talking to a data architect. Right now, when we write SQL, we are talking to the database. When we use an agent, we are talking to the architect. The architect understands our intent and handles the low-level communication with the machine. This architect has perfect memory of every table, every index, and every query plan in the system. That is something no human can compete with.
It is interesting to think about how this affects the developer's daily life. If the database can evolve automatically, then the API that sits on top of it can also evolve automatically. You don't have this lag where the backend team is waiting for the database team, and the front-end team is waiting for the backend team. The agent can update the schema, the ORM, the API endpoints, and the front-end components all in one go. That is the dream of the full-stack agent.
It is about turning the anchor into a motor. The database has always been the anchor that slows everything down. If we can automate the evolution of that layer, the speed of development will increase by an order of magnitude. But we have to be careful about the risk of generating a mess. If an agent is just adding columns and tables every time it needs a new feature, you could end up with a very bloated, inefficient schema. We still need those architectural principles. We still need normalization, even if the agent is the one implementing it.
This is where the specialist models might have an edge. A model that is fine-tuned on database design patterns will know when to suggest a new table versus just adding a column. It will know when a polymorphic relationship is a good idea and when it is a recipe for disaster. We are moving from the era of coding assistants to the era of design partners.
And if migrations are ephemeral, then refactoring becomes much more attractive. In the current system, refactoring a database is so hard that most people just don't do it. They just keep piling new stuff on top of the old stuff until the whole thing is a giant ball of mud. If you can say to the agent, I want to normalize these 3 tables into 2, and the agent handles the transition and verifies the state, you can keep your technical debt from accumulating.
It is like having a constant automated cleanup crew for your data model. But for this to work, our tooling has to catch up. Most of our current deployment tools are still built around the idea of running a sequence of SQL files. We need tools that are state-aware and agent-friendly. We are starting to see them, like new database platforms that treat the schema as a first-class citizen with built-in versioning and branching.
You can branch your database just like you branch your code, run your migrations in the branch, test them, and then merge the schema changes back to the main branch. When you combine that with AI agents, you have an incredibly powerful workflow. It is a complete reimagining of the back-end developer's life. Instead of being a plumber who is constantly worrying about leaks and clogs in the data pipes, you are an architect who is designing the flow of information.
It really feels like we are at a turning point. The old way of doing things, the manual, high-friction migration grind, is just not compatible with the speed of AI-driven development. We are either going to change how we manage databases, or the database will continue to be the bottleneck that prevents us from realizing the full potential of these agents.
I am optimistic. The tools are getting better every day, and the reasoning capabilities of models like Claude are reaching a point where they can be trusted with these complex tasks. It is not about replacing the developer, it is about giving them a much more powerful set of tools to work with. It is about breaking out of that straitjacket. When the database is no longer something you fear, it becomes a place where you can innovate.
If the schema is no longer a straitjacket, then the only limit is our imagination and our ability to define what we want our applications to become. I think that is a great place to wrap this up. We have covered a lot of ground, from the pain of traditional migrations to the promise of agentic schema evolution and the radical idea of ephemeral migrations.
It is a fascinating shift. If you are a developer, start experimenting with these agents in your database workflow today. Use them for the small things, build your trust, and see how much faster you can move when you are not constantly fighting your ORM.
Well, this has been a deep dive into the guts of the back end. Thanks as always to our producer Hilbert Flemingtop for keeping the gears turning behind the scenes.
And a big thanks to Modal for providing the GPU credits that power the generation of this show. Their serverless infrastructure is exactly the kind of modern stack we are talking about here.
This has been my Weird Prompts. If you are enjoying these deep dives, a quick review on your podcast app really helps us reach more people who are interested in the intersection of AI and engineering.
We will see you in the next one.
Later.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts.